Indefinite integrals. We can think of integration as a reverse process to differentiation. Indeed, it is often referred to as anti-differentiation, a term I myself am not keen on for reasons I'm not going to here. The basic ones that we should know are the integrals of the functions that we have learnt to differentiate. For example, the integral of ax to the n with respect to x is ax to the n plus 1 divided by n plus 1 plus a constant. Let's just look at differentiating that. If I had ax to the n plus 1 divided by n plus 1 plus a constant, and I differentiated that, then what would happen? This n plus 1 up here would come down and multiply the ax. We would reduce the power by 1. That's divided by n plus 1. And of course the constant would disappear. And then the n plus 1 on top can cancel with the n plus 1 on the bottom. And we end up with ax to the n. So it stands to reason that when we integrate ax to the n, we get ax to the n plus 1 over n plus 1. We'll discuss the constant a bit more later. So in the same way, it follows that we have, if we integrate e to the x, we get e to the x plus a constant. We know if we differentiate sine, we get cos. Therefore, if we integrate cos, we get sine. We know that if we differentiate cos, we get negative sine. Therefore, if we integrate sine, we get negative cos. With the trigonometric functions, it's usually best to think of the cycle shown here. Sin x, cos x, negative sin x, negative cos x. If we're going this way round, we're differentiating. If we go the opposite way, we're integrating. You really should learn this cycle. We can get other integrals based on these functions by using the reverse chain. And note, reverse chain is in quotes. I'm going to talk more about the reverse chain shortly. The plus c was discussed in the Year 11 course, but in essence, we know that if y is x cubed, then dy dx is 3x squared. If y is x cubed plus 5, then dy dx is still 3x squared. If y is x cubed minus 2, then dy dx is still 3x squared. So when we integrate 3x squared, we acknowledge the family of functions that we could get. Hence, the integral of 3x squared dx is x cubed plus a constant. So if dy dx is 3x squared, it follows that y is x cubed plus a constant, which results in a family of solution curves. Essentially, our c could be anywhere from negative infinity to infinity, which gives us an infinite number of solution curves. They'll all be the same shape as x cubed, and indeed x cubed is the one that goes through the origin here, the one in blue. They are all vertical translations of the y equals x cubed curve, and we'd expect that when we add the c. We know that that is going to translate the curve vertically by c units.